For you, please do introduce yourself and take it away. Thanks.
Thank you. Good afternoon. My name is Matt Yonkman. I'm with the Emerging Threats and the Open Information Security Foundation. And talking as well in a couple of minutes will be Ivan Ristic, the mod security guru, the man behind every secure web server on the planet, I think. A couple of things we want to talk to you about today. What's going on with the Open Information Security Foundation. And I'm going to get a plug in for my other project, Emerging Threats, as well. That one might be a little more well known. The session, especially the part when we start talking about IDS and what we want to build into it, I want it to be a brainstorming session. That's what we're going around doing. We want to hear what you want in your IDS, what problems you have with what you have now. So we'll have a quiz at the end, and for everyone that has a good question or a good contribution, we've got lovely Emerging Threats lanyards, which are also for sale. If you don't earn one, we sell them on the website. It helps support Emerging Threats to keep the rule sets free. So come up with a good question in the meantime. Otherwise, €5, which is what, about $35 now. So it's a really good deal to buy them in euros. So, and if we have a little time, I'll touch on the SandNet, but that's just to fill time, just in case. So again, my name is Matt Yonkman. EmergingThreats.net is the new home of what used to be Bleeding Snort, Bleeding Threats. If you're using Snort and Snort rule sets, you probably are aware of them and are following us. Just a little bit about it. It's about 6 years old. We're 10,800, 10,900 rules now active. We've had about 15,000 rules come and go. A lot of them are time sensitive or replaced, consolidated. It's all BSD licensed, which means you can use them in your commercial product without notification. Do whatever you like with them. You don't have to give us anything back. We ask for, and almost every commercial vendor that we're aware of is really good about when they find something of interest, they contribute a rule back to the rule set. So that's really all we ask. And that feedback cycle works very well. Performance fixes, new vulnerabilities, new signatures. It benefits everybody to share a signature back. In the past, and what's brought us to where we are now, we've been funded by the Army Research Office, National Science Foundation, SRI, which is Stanford Research Institute, which they get their cash from DoD and a lot of other folks. So we've had a lot of interesting things that have brought Emerging Threats to where it is. We've not had a lot of financial funding. We've had infrastructure, things like that. But we do sell T-shirts, lanyards. We have coffee mugs that'll be out next week. We do those kind of things to help support the infrastructure and keep the rule set alive and free. So not only do you get a nice, soft lanyard, but you can help keep the rule set free. Here are some of the rule sets that we run. We have a pretty well-covered range of threats. Everything from policy violations, excessive eBay use, to the latest SMB exploit and the latest malware. Our real focus, though, in the project is malware, command and control channels, data posts, information leakage, things like that. And that's what most commercial rule sets do not cover, primarily because it's a lot of research to do, a lot of chance for false positives, but it's a very valuable rule set to run. The emerging malware and the emerging user agents rule sets. Those will catch most all malware that's out there nowadays. Not all, nothing gets all, but we get a vast majority of it. We also have some IP-based rule sets, things for known spamming nets. Spamhaus publishes a list of net blocks that they know are owned and used by spammers only. Why bother talking to them? So we have rule sets that give you an easy way to block on those. Compromised hosts, people are doing SSH brute forcing, known Zeus controllers, known all sorts of good stuff. Russian Business Network, we've got a bunch of guys that do, some law enforcement connected even, that do very good research on the Russian Business Network. They follow them very closely, and that list is very useful, very accurate. Not only will it block spam for you, but it's going to block a lot of Trojans, bank stealers, things like that. The very good ones, very organized ones. So a lot of good stuff, a lot of different things we have at Emerging Threats. And most of those we also have in versions for rules for firewalls, routers, where you can just put a drop or a shun list. We also have a SandNet, which is what generates most of our malware signatures. And this is a custom-built SandNet that works differently than most of the software SAN netting systems. We use live systems, and we capture traffic, compare it to the rule sets, and all volunteer analysts. If you're interested in learning something about malware, about writing signatures, about command and control channels, what's new in malware, volunteer to work in the SAN net. It's a fun thing. There's no obligations to it. We'll just check you out to make sure you're not somebody we're trying to catch, that you're somewhat trustworthy. And you get to look through the output of the SAN netting and see, do we have a signature that covers this well already? If not, can we write one? And then go about that. And it's a very collaborative process. It's a great way to learn about malware and learn about write signatures, learn about how to write signatures. You don't have to be an expert to get in there. There's a lot of very good mentoring that goes on. So if you're interested, shoot me an email. We can always use volunteers. An hour a week, something like that is all it really takes to get into it and stay current. And you'll enjoy it. It's good stuff for Saturday night if you have nothing to do. You can also submit samples to the SAN net. If you're interested, hit the website. So that was my quick plug for emerging threats. Any questions or anything about that real quick? Yes, sir. Right now, our rule sets. Sure. The question was, do we run just static signatures, or are we doing heuristic-based things? The rule sets we write are primarily for Snort, which is all static signatures. There's not a heuristic engine to be used in that regard. We also do things to identify malware command and control channels using heuristics in the SAN net, but we generate static signatures out of those. So we would go heuristics, but the engine doesn't support it right now. Anything else? Good. And don't forget lanyards for sale, T-shirts. That's how we keep the project alive. Our lovely assistant there. All right, the Open Information Security Foundation. This is the big, exciting thing going on in our lives right now. The problem that brought the foundation around is, consider over the last 5 years what's really changed in IDS, in Snort, in ISS, in Juniper, in all the commercial engines. What's really changed with them in the last 5 years? Some have gotten a little faster, maybe. Compilable rule sets, maybe. Not much has changed, really. 5 years, a major technology that we all rely on for security, that our banks rely on, that our governments rely on, hasn't really changed in 5 years. That's 2 lifetimes in the computer world. It hasn't really innovated. We have new information, we have new data, we have new ways to find bad things going on. We haven't shoved it into our IDS yet to do it real time. The IDSs really haven't remained open to collaboration, commercial ones especially. You're never going to see source code of your ISS or your Juniper. And they haven't really integrated with other technologies. There are so many different things that we could use in real time that we're just not. We're not going there, we're not trying. So the goals with the Open Information Security Foundation: bring new technologies into IDS, not just build another one, build something very different, very new, larger in scope, more risky, more experimental, but we have to make a step forward. 5 years is way too long. We're stagnant. We're all shunning our duties. We should have been innovating much further, much faster. We need to scale. We need to take advantage of multi-processor systems. There's not a multi-threaded intrusion detection system on the market. Just mind-boggling. Why haven't we done that? We need hardware acceleration integration that is easy to use. There's Bivios out there, there's Endaces, a lot of different vendors that build platforms that can accelerate capture and analysis very effectively, but they're difficult to use. One of our goals is to make sure you can compile, it can sense its environment, and very effectively take advantage of the platform you're on, working with the engineers that make those platforms. And to keep this open source long term. So how are we going to do all that? We don't want to make a replacement for what we have. We want to make a significant step forward. It's going to have to do what we do already, but it's got to do more. So why should we do it? Why is DHS funding this? We're going to do it in a nonprofit. Why use a nonprofit? Well, really, no commercial vendor can really take their IDS product, toss it, and start writing a new one, add new technologies, new features, new experimental things, and expect it to be picked up by the market. I mean, IDS right now fits the box for PCI compliance, for your security pen tested report, your vulnerability reports. You have an ISS, one of the commercial 5, 10, you're good. It fits the box. Nobody's going to pay more for something new because they already have what fits the box. So we really need to do that outside of the commercial sector. It's just not commercially viable for one vendor to do that and expect to sell it. So we're going to do it. Why do we do it with a nonprofit? Well, if the nonprofit owns the copyright to this code, we're a nonprofit in the United States, under U.S. tax code, that nonprofit can't sell the code, it can't give it away, it has to use it, and it always has to fulfill its initial charter, which for us is to build an open source IDS and make it free to the world. So we're legally bound to continue to do that for the long term. Why are we doing a nonprofit besides that? Well, donations and support are tax deductible under U.S. code. So that hopefully will bring us a lot more vendors, give them something to contribute to, and actually receive a tax benefit for. We're obligated by law to uphold our primary goal, which is pretty much do good for the world. We're going to build a next generation IDS engine, make it free to the world, maintain it for the long term. There's the kicker. That's the one that's going to be the challenge, but we think we can do it. Now we've come up with a name, which actually proved to be about the most difficult thing we've done so far. We have a lot of code generated, but finding a freaking animal that, for a mascot that wasn't already used, that's tough. I mean, think of an animal right now, and I'll bet you there's an open source project that's using it. I mean, the green-toed Amazon tree sloth, it's used by something. So we found a meerkat. Now, Suricata is part of the Latin genus name. It's a cool-sounding name, we thought. The meerkat kind of has the always standing and alert, always watching while everyone else is working. Somebody's always watching. It's kind of the idea behind the logo. So, but you're not here to hear about the logo. So, long-term support. We're building a consortium of vendors and other interested parties that want to use the engine in a commercial product. Now, we realize we'd all love to be open source hippies and make this totally free, totally GPL, and to use it in a commercial product, you have to release your code. We know that won't work. We have to come up with more of a balance so we can have the vendors involved, them have some assurance that the product's going to last long enough for them to build a product or an appliance around, them to have some guidance into the development, and where they have expertise, they can contribute that to the engine and not only receive a tax benefit, some kind of a relationship benefit, but they can also get a version of the code that is not GPL encumbered, so they can build a commercial product around it easily without having to release everything else that they build around it. We've had some very good input. We have 5 committed consortium members already, significant ones. We have about 15 more that are kind of, well, let us see your first release and then we'll jump in if it fits us. So members contribute. They get a GPL unencumbered license. They get some input into the development. What direction should we go? And so, hey, we got a guy that is spectacular multi-threading. You can use them for 10 hours a week, that kind of thing. Those kind of contributions are where we're going and why we're doing what we're doing. So our board of directors, we're just actually about to announce next week, but we can talk about them now. Jose Nazario from Arbor Networks. Now this is our board of directors, people that actually oversee day-to-day operations. Myself as the president, I answer to the board. Jose Nazario with Arbor Networks. If you know the guy, he's one of the biggest brains in our industry, especially as far as large-scale data gathering, which IP reputation is one of the things we want to do, so Jose will help us a lot there. Jennifer Steffens, now with IOActive, formerly with SourceFire. Very good at building communities, community relationships, and keeping us licensed correctly, I think. Stuart Wilson, he's the CTO of Endace, which is an acceleration platform manufacturer. We're really hoping to use his expertise, and Endace has helped us a lot already with nearly $500,000 worth of test equipment and generation hardware. We're hoping to use Stuart's expertise to make sure our hardware acceleration works well, and we work with all the other vendors well. And Mark Norton, who's now with BEA, one of the original SourceFire coders, formerly SourceFire, really is teaching us a lot about how to develop a large-scale, high-speed platform quickly, not repeating the same mistakes that have been made in the past. So that's our board, as well as myself as president. We're very excited about that board and the expertise that it brings to the project. Our status right now, we have about 20 programmers working mostly full-time, a few part-time. We're looking for more as well. If you're interested in coding, primarily C, of course. If you're interested in doing some work part-time, full-time, or even just have an idea you'd like to try and implement, let us know. We're well-funded. We're paying people a good rate, and it's enjoyable work. It's a lot of fun. We have over 100,000 lines of code. We have our 5 initial consortium members. A little bit about the team. Myself, we have Victor Julian, who's been the lead developer for Snort Inline for quite a few years now. He's overseeing coding on this, and really most of the code and the framework is his brainchild. Will Metcalf, who's also a Snort Inline guy, is our lead quality assurance guy. And our QA lab, I have to say, is spectacular. A lot of vendors have given us a lot of very expensive hardware, and we love playing with it. It's a lot of fun. But we're building a really good engine on it. It's testing very well. We have a professional project manager with a lot of government contract style experience, keeping us on track. We have Ivan Ristic, the man with HTTP, is building our HTTP parser. We couldn't think of anybody better in the world to do it. I don't think anybody knows more about HTTP and how to break it than Ivan. So we're excited to have him doing that. I don't expect anything will have a better HTTP parser than our engine is going to. We have Kirby Kuhl with Breaking Point Systems building an RPC decoder for us, which he's done twice already. So third time should be bug-free. Let's hope. We have Brian Rectanis, also with Mod Security, Breach Security, doing a lot of coding for us. Jamie Ryden, some of these other folks you may not know, but they're very interesting people. And a lot of these we found because they wrote a good white paper and had an idea about something to try. We called them and said, hey, would you like to try and implement that? So Jamie Ryden, Oxford kind of guy. Gervinder, and I had to cut and paste his credentials. It's just horrendous. But very, very intelligent Indian man that's going to college in Norway, finishing his master's. Brilliant. Implementing some very incredible things. Anoop, former RSA guy, high-end coder. Bruno Silva, he's Brazilian. We have quite a few Brazilian guys on staff. We have Eben Moglin, who wrote GPL v3 as our primary counsel. So I won't go through the rest of the team, but suffice it to say we're finding the best and brightest anywhere in the world. In fact, even though we're based in the United States, we only have 2 U.S. employees, 3 out of 25. So we're picking whoever comes to us that can do the job the best is getting the work. And that's really what we're seeking, is more folks that have an idea or you're passionate about something, you have some code you want to try. Our charter by DHS is to do something different, do something new, not build anew what we have. So if you have an idea, please come to us. We are looking to double our staff in the next 2 or 3 months. So our current consortium members, we have Endace, hardware acceleration vendor. They have a very good platform. Bivio as well. They also have a good platform, a whole different concept in acceleration. So having them on board gives us access to their engineers, and we'll build the engine to take advantage of both platforms, but not at the same time, of course, but independently. And without having to re-engineer how you do things, to be able to build the engine to compile and take best advantage of it out of the box. Everest, which is a smaller consulting firm, but they do a lot of intelligence work, a lot of Army, Air Force work in the United States. They're bringing a lot of technologies that the Air Force wants to declassify and give to the world. They're going to come through Everest and come to us. So we're going to have a lot of features that just pop up out of the blue and say, hey, here's a new way to track X, and it's been donated by X. So a lot of good things coming there. Nitro Security, appliance vendor, they're very, very helpful to us. Breach, of course. lots of different companies. And like I said, we have about 10 or 15 more that are waiting for us to finalize license terms and also want to see the first release. So we expect to have a large vendor contingent. Now, the reason we need those vendors is the long-term support. DHS is going to fund us this year, next year, and probably a little more after that. But long-term, 5 years down the road, we need the vendors to not only be hooked on the product and use it, and it works for them, but they have a motivation to keep contributing to the consortium for bug fix for continued development. Now, we want to do that cheaper than it would be for them to buy a commercial product and applianceize that or write their own. But with many of them together, keeping 2 or 3 guys on staff for the long term to maintain the code should be quite easy. So our primary goals. Our first release, phase 1, December 31st, 4 weeks away. And we're real close. We're going to hit that without a problem, I hope. No, we'll have code out December 31st. And this will be, phase 1 has a few of the new features, one of the biggest ones being multi-threaded processing. So December 31st, you'll have access to an IDS, multi-threaded, that uses the Snort syntax. There we go. Some of the major features we're going after. And here, if you have questions or contributions, things to add, please speak up and let us know. Because this is really the IDS we're building for you all, for everybody. So native IP6 support. Of course, we all have to go there. Native hardware acceleration support. Endace and Bivio platforms are primarily what we're building to right now. We're looking to reach out to others. So far, I haven't had much response. But if there's a platform you're interested in that you use and you would like to see acceleration compatibility for, please let us know and help us get in touch with their vendor. Multi-threading, of course. We're seeing in testing on stock, everyday hardware, at least a 10-fold increase in throughput and processing just by going multi-threaded with 2 or 3 processors. Significant, huge change. IP reputation. This is one that is near and dear to my heart. What we mean by IP reputation is we have massive databases of information about bad IPs and good IPs. Spammers, command and control servers, infected bots, good places, Google, Yahoo, Acme, things like that. If we were able to look at the reputation of an IP and know something about it, we could write rules that were a lot more reckless. Reckless rules are good because a lot of times we sacrifice detection because there would be too many false positives. Well, if we could say, if this happens and we know this IP has a bad reputation as a command and control server, then we can create an alert. If it has a good reputation, we don't create an alert. Now, there are potentials for false negatives as well, but combined with a more reckless rule set and our next thing, scoring thresholds. So we use the Spam Assassin style alerting based on this rule hits, you get a 1/10 of a point. This rule hits, you get a 1/2 point. This one hits, you get -2 points. That kind of, we'll use everything we know about you instead of just one black and white decision. We can use reputation in conjunction with scoring thresholds. We can make rules that are not only more accurate, but we can go after things normally we wouldn't be able to go after, in IDS especially. I mean, there are a lot of malware that make their command and control channel look just like a regular HTTP stream. And some of those, especially Zeus, we can't go after because it looks too much like normal. But if we can combine reputation and a couple other factors, we can get them every time. But nothing can do that right now. Global flow bits and variables. If you're familiar with Snort, you'll know that in most IDSs actually, you can remember information about a connection, but only for that stream. You can't remember that for the next stream or the next stream, or even globally. So what we're adding is essentially a global state database, where you can say, if this happens, save this variable, and not just a bit on or off. You can actually pull data out of the packet, save that in the global state database. and then 10 minutes later, compare that and say, hey, they already tried to log in as Bob, and now they're logging in as Sue. Yeah, that's not right. Something's wrong there. So a lot of good things there. One of the major problems that we hear from a lot of new users with IDS is it's too tough to learn it. You have to learn everything about it in order to turn it on the first time. The learning curve is way too steep. So what we want to build, what we are building is a web-based config manager, where it'll come up and give you some defaults, some explanation around them, ask you some questions. What kind of network are you putting this on? What kind of traffic do you have? What do you care about seeing? And it'll walk you through and give you a basic config to start. Now you can still configure it normally with a text file, as we all do once you understand it better. But this way, the average user can get in, click a few buttons, answer a few questions, and have a running install. It's not just going to overwhelm them with crap. And well-parsed HTTP. That's one of the things. Malware is all going HTTP and HTTPS. So being able to really pull things out of there easily, quickly, without having to parse an entire stream is very important. And here's where I'd like to turn it over to Ivan for a few minutes to talk more about what he's doing with that. I think that'll work.
Thanks. Hello. Matt was kind enough to invite me here to tell you a bit about the part that I'm doing, which is all about HTTP intrusion detection, really. For those of you that don't know me, and I guess that most of you won't know me, I sit firmly in the application security space. So I've spent quite a few years now just exploring the ways of making web applications more secure by the way of adding things in front of it, in front of them, which is web application firewalls. If you don't know about mod security, it's the most popular web application firewall, and it's open source. Web application firewall is the name that clients recognize, but it's really it's an HTTP, it's an intrusion prevention system built for HTTP. So what I'm doing right now is I'm building this special HTTP parsing library. And the idea is that this library is going to be fully security aware. It's primarily designed for use in intrusion detection systems, IPSs, and web application firewalls. So it's not a web application firewall, but it's just something that provides information to a web application firewall or an IDS. And it's designed to either be entirely passive. So you sit somewhere, you're observing the traffic passing by, and you try to reconstruct an HTTP traffic stream, or it could be used if you want to terminate traffic in a proxy of some kind. And this is very important because the really difficult part is doing everything passively. And the reason why this is difficult is because there are so many ways to evade detection and to evade parsing, break parsing, and so on and so forth. Naturally, the reason why I'm here is because this parser is going to be in this release that the foundation is going to make in December and afterwards. So you should care about this because the way things are going, HTTP is used more and more and more, and you may be using various IDSs and IPSs to inspect HTTP today, and these evasion issues are not really well documented. My guess is that most tools are simply not able in keeping up with what HTTP can throw in them, and you don't really know what your tools are capable of. And in the future, the importance of HTTP is going to increase, and so we need to deal with this problem effectively. And at the root of all this is what I like to call impedance mismatch, and this is especially problematic if you're entirely passive. And there are two root causes. One is the ambiguous protocols. And I say protocols, but in some cases in HTTP, we don't really have protocols. We have some nodes that were made by some engineer years ago, and no one is really sure how to implement certain things. And the other big problem is faulty implementations. Again, when you say faulty implementations, you may think of bugs as root cause. But in real life, what I'm finding is that people don't really try to implement protocols. They just throw together anything that appears to work at the first glance. But that effectively allows, there's a lot of room for interpretation, and every single thing that you can throw that's slightly different can actually be abused in a situation where you have one service at the back end consuming traffic, and you're in the middle in the IDS trying to interpret the traffic in the same way. So basically, that's the idea of the library. We want two things. One is to see the traffic in the exactly same way as the backend will be seeing it. And the other goal is while we are parsing this traffic, we want to make sure that to detect various evasion attacks. So basically, the way I see the problem is that an IDS or web application file is like this big shield. And at the first glance, it looks like this shield is really solid and you can't do anything with it. But the truth is that you can't do anything to it if you try the brute force attack. But our shield has a lot of these tiny cracks. And once you start looking for these small cracks, you can try to go through them and completely avoid the shield. So basically, the attacker only needs to find one weakness in your HTTP parser, and that can be a complete bypass of all the HTTP rules, and that's obviously not very good. Some of the attack strategies, and this is a sort of, as I said, the lightning talk, so I can't really go into detail, but here are some of the strategies that attackers typically use or would use. One is to hide payload, and that doesn't have to be anything particularly smart. Using SSL or compression will often throw off IDS tools. The other strategy is to fool these monitoring products into seeing something different from what the backend will be seeing. And this is usually the case where you have a lot of impedance mismatch. And you can, if you've ever heard of request splitting, it's a concept where you make the monitoring tool into seeing completely different requests and responses from what the backend is seeing. And obviously, this is how monitoring tools completely miss data and attack payloads. Then there's ample space for obfuscation, especially for when you're talking about web applications and various other application protocols. And if you think about it, each web application creates a protocol of its own. So as soon as you start moving towards the HTTP, the problem gets more and more difficult. The forward attack strategy is attacking decision points. And this is something where HTTP is different from IDSs. What I have found with application files, you tend to have fine granular policies because you will have to use basically one policy per application. And that's why these tools need to understand what makes an application. They need to understand sessions, users, and scripts in order to provide effective protection. So in slightly more detail, this is just a brief look through the categories. SSL is not really an evasion technique, but it's very effective because tools often can't see through it. Then it's breaking TCP streams into HTTP messages because the way a monitoring tool sees these messages has to be exactly the same as the backend tools. Then you have message parsing where you have request headers. Using techniques such as request folding or putting headers into trailers and things like that. Compression and chunked encoding, which is, again, often not supported. And then once you start to drill into it, you can see this is exactly how parser would parse a traffic stream. You start to drill into various problems, and you look into query string and request body parsing, file uploads, character encodings, and even then you finally reach application level payloads. So the truth is I have here about 8 rough categories, and in my notes I have notes, pages and pages of notes that maybe have dozens of different evasion techniques that work or don't work in some of these cases. So the real challenge here is actually understanding that the way traffic is consumed does not really depend just on the web server that is used, but it depends on the web server, on the application server, on the application itself, and whatever else the application is using in the backend. So if you take your 8 categories with dozens of different evasion techniques each, and then you combine that, then you have a look, and then you have a number of applications and web servers and whatnot that you have, you really have a huge amount of combinations that can or cannot work against a particular product. So I guess where this is going is that you have to understand the context in which your monitoring tool is running in. And in that context, you have to know a lot of information about every host in order to figure out exactly how to parse that information. So I don't think that this is particularly difficult to do, but there's no good research at the moment. The best research that I found is the request splitting research from 2005, and it's slightly obsolete by now. It has to be redone. When I first started writing the code, I actually had to make a break and start researching. And my idea of going forward is to actually automate this research so we could automate all the tests on discovering deviation points for single products, and then we can use tools to combine them and to figure out how, and have a completely configurable parser that will provide the exact output as the backend systems would. So I was trying to be as brief as I can. If you have any questions, I'll be around later. And now back to Matt. Thank you.
Thank you, Ivan. For a lot of reasons, I'm glad he is working for us and not the other guys. So HTTP, just one of the many things that we found the best minds in the business to solve the problem for us. People have done it before, people that work in it every day. Not taking a general purpose programmer and asking them to build things they're not familiar with. We're doing the research, we have the funding, we have the backing, we have the time to do this all right. The engine, I think, is going to be spectacular. The testing we've done on it so far is beyond spectacular, more than we expected in our first release. So get involved if you're interested. Join our mailing list. We keep updates coming across there. We have code coming out December 31st, so that the traffic on the mailing list is going to increase significantly. We'll have betas out very soon to play with. We don't have the code repository out to the public yet, but if you're interested in looking at it, just let us know privately. We don't want to have people pull the code base and try it out knowing that it's broken and not complete yet. We'd rather wait a little bit till we have a beta ready to go. Code with us. Like I said, we're looking for full and part-time coders. Even if you have 5 hours a week, if you have a cool idea or you're interested in doing this and want to get into it, whether you want to work for free or paid, we recommend you work for paid because we have the money, we're well funded. DHS has been very generous with us. Like I said, we're looking to probably double our coding staff in the next 2 to 3 months. We have phase 1 release, which is December 31st, phase 2, somewhere next year, probably about 6 months down the road, and that's where our major changes are going to be. The primary IP reputation stuff, everything we learn out of our phase 1 release, fixed in phase 2, of course. And join the consortium. If your company is interested in using this as a dual license, getting into this early as a consortium member will be much cheaper than it will be down the road. And the point of the consortium is not to bilk our vendors of millions of dollars. We don't need much to maintain this. We have a lot of other funding, and we have grant money that still comes. What we need is the support. We need some of the engineers out of some of the companies. There are a few companies that employ one of the 3 people in the world that know how to do a particular thing very well. We can't afford to buy these guys outright, contract, so if we can get their company interested and use them for a few hours a week, that works out better for everybody. So, what do you want in your IDS? And free lanyards, and a free lanyard for the question earlier as well, but if you have a good idea, free lanyards. I mean, what's your IDS not doing for you now? What's frustrating for you now? Good, we covered it all? We have been through quite a few brainstorming sessions, and we've had really good feedback, and I think we've got it mostly distilled down to the major features we're going after. There are a lot of smaller things, especially like the multi-threading framework we're using, the capture frameworks that we're using, that I think you're going to be excited with that have come from a lot of feedback. Good. All right, thank you for your time. Oh, question. Yeah.
Sorry if I get too much into detail now, but
No, please.
What are you doing about obfuscated JavaScript in HTML or in PDFs?
That's a good question. I don't think we're doing much for it at the moment in phase 1. It is something we've discussed and would probably have to be something that Ivan would solve for us. What do you think?
Am I on? At the moment, we don't have the functionality is not in the first release, but it naturally belongs in the parser because although we call it HTTP parser, it's really there's so much stuff that's it's not really just HTTP. There's several specifications. So JavaScript would probably go there. So deobfuscation would go there. What I would like to see is a complete HTML parser first. So you have to normalize HTML, so you can extract the small Java snippets, and then you figure out what to do with them, and then only then you can really deobfuscate.
And something down that road that we're looking at doing is to be able to spawn an external script. So you could write your own Ruby, Perl, something to that effect, to where you say, this rule hits, give this entire packet, or give this information, or give this whole stream to this script. Now that wouldn't be done inline, it wouldn't be done real time. It would be kind of side processing, post-processing. And being multi-threaded, we can do that. If you put a 12-core box in somewhere, you can let all sorts of things go off to the side, and it's not going to affect throughput. So, and one of the reasons why I wanted to give the accessibility to run whatever script you want is we have a lot of people that know a lot about IDS and threats, but they're not programmers. They can hack Perl, they can hack Ruby, Python maybe, but they're not going to be able to write effective C and be able to do something good with it. So that kind of gives us access to easier languages to use. May not be as fast, but they're running to the side. They're not part of the main processing flow. So, yes, sir.
Since the Intel architecture only has one cache line to multiple cores on a single processor, how are you actually getting any throughput or performance improvements by being multi-threaded?
Well, primarily the bottlenecks in the past have not been actual passing packets. They've been processing, CPU side. We've gone past all the capture and IRQ binding, things like that by using PF-ring, those kind of things. And I'm probably not the best guy to answer the question, but like I said, the bottlenecks have not been necessarily pushing enough data through the motherboard. It's been processing effectively with a large rule set and rules that you want to run but maybe are high load. So the performance testing we're doing is with full rule set, everything turned on. Is that, no, not SO. Including SO rules, no, we're not able to use those, unfortunately. Yes, sir. We may in the future on SO rules, but we still have to work through it.
You're working on wiretapping as much data as possible. Do you are working on cutted data, for instance, flow information, or only a single protocol like DNS snap, and try to find that something is going wrong? I'm coming from ISP. It's nearly impossible to put an IDS full stream in upstream of our customers, but would be fine to have an IDS that says, so look at this customer, it seems to be very scary at this time in the moment.
Yeah, well, one of the concepts we're going after is making this very modular. So you can plug a module in, doesn't have to be a pre or post processor or anything like that. You can just have rules that trigger traffic to go to that preprocessor or that module. One of the things we want to do, and one of the things that a white paper's been presented to us, and we're getting the guy on board to code this, is to take DNS and do long-term evaluation of DNS lookups. So you could build the IDS, and this will be, each module will be a library as well. That's something I should expand on. Everything that's possible in the engine, we're building into individual libraries. Now, the entire engine itself could be libraryized, but if you're looking at, you just want to use our TCP reassembly code, that will be just a library that you could just use for anything else. Same with other things. So the DNS parser we want to build would look at, it's primarily centered around malware. So statistically, it could look at over time if one host on a network is looking up, making more DNS requests than everyone else on average, and it's, that's something of interest. A mail server, of course, is going to do that. Those things could be excluded. But if you have a regular host that looks up significantly more than the others, that's of interest. If you have domain names that keep getting looked up and we're always getting low TTL and new IPs, that's something of interest. Combining a lot of different factors of DNS, primarily to find fast-flux malware, CNC-based on DNS, things like that. That's probably, I imagine, what would be of most use ISP-wise. But you could build that just to look at DNS traffic, tell the engine only port 53 as usual, and probably get really good information out of that without actually even having to do deep inspection and getting into your customer's business. Yes, sir? Oh, sorry. Let me go there first and then. Yeah.
Yeah, I do post-processing of captured data. I want my IDS to output the alerts straight into a database. Do you support that?
Yeah, well, right now we're looking at supporting the Snort Unified output. So we could drop into Unified and then use Barnyard or something to go straight out. A module that we probably won't have in phase 1, but will be shortly after, is to be able to write straight to rotating TCP dump buffers out of the engine so that you have anything that generates an alert, a certain amount of time around that is kept in your rotating buffer, or you can do full capture to the rotating buffer. Does that answer your question fully?
I think so, yes.
Okay, good. I appreciate all the questions, by the way. We love to get new ideas, and we've come up with a lot of hurdles we had to solve by questions asked in the conferences we're going to. Yes, sir.
What about correlations between different customers? What can you do? Could you do something in real time, correlate, not just traffic between a single customer, but customer quotes?
Yeah, well, that's where we're really trying to go with IP reputation. Is anybody familiar with the product called SnortSAM, or an open source project? What SnortSAM is it's a kind of a crude IP reputation where you can take, it has a plugin for Snort, and you can define a rule that says if this hits, block the source or destination for a certain amount of time. SnortSAM takes that and then distributes that to firewalls. Now, it's a really good product, it's a really good idea, but there's no gray area, it's block or no. So IP reputation is kind of where we're wanting to take the next level of that. So within an organization, you could use reputation between sensors to share. So if somebody starts beating on one entryway to your network, everyone knows about it. They start to get a bad reputation as a scanner, attacker, reconnaissance, things like that. So all the rest of your sensors would, within a couple of seconds, know about that IP. Now, when we start sharing that information between major sites, it gets even more interesting. We did an experiment with this, what was it, 2002, 2003. For about a year, we ran a network of SnortSAM sensors in a major university in the US. It had 2 Class Bs of traffic, gigabits, going through even in 2002, 2003. Massive amount of traffic. Every third PC on the network was infected with something, and all the rest of them were file sharing. It was horrendous negative traffic. Anybody that was going to attack anybody eventually crossed those 2 Class Bs. So then we shared that data with, at the time I was running a managed security provider. We had about 40 or 50 banks, manufacturers, all sorts of folks. On the average, each of the clients there would see 1,000, 1,500 events a day. When we went to this, where we were blocking everything that was seen at the university, and vice versa, the university went quieter, and our clients went from 1,500 to 250, maybe 300 events a day. Because all the people that were attacking them, causing the regular noise, there was already a block rule for them because they'd already been through the university. Now with the IP reputation, we're wanting to take that up to the next level, to be able to have granular reputation, very good, very bad, and categories, spam, attacker, exploit, RFI, things like that. So does that answer your question? Yeah. Yes, sir.
Sorry, one more question.
Please.
You said you were getting good performance, but you didn't define good. What is your definition of good?
Well, we're still in the QA cycle. Our goal for this release is to have 10 gig with full rule set on a multi-core box. Now, how we define that, still coming down to how we build out our QA lab when it's complete. But like I said, we're looking for the 10 gig range. I mean, if we don't get there, we're not really doing something new. So, like I said, 10 gigabit, stock hardware, multi-core.
How are you defining 10 gig, and what's your test?
The actual test that we're going to use for numbers hasn't been fully defined yet. What we're doing right now is we're using PCAPs from universities, pushing those through Endace boxes, and we can push 10 gig a second and not lose packets. but the engine isn't totally complete yet either. We're still processing all rules, or 95% of rules that are available in the VRT and in the emerging threats rule sets. No packet loss, and like I said, around 10 gigabit processing. We still have modules to add though.
Does that include stream reassembly and fragmentation reassembly?
Yes.
Thank you.
But we haven't fully pushed the stream and fragmentation to the limit. I mean, right now we're still making things work first. Really stress testing reassembly is coming up yet. But we're going to, all these testings, the methodology for our testing and results are going to be out. And we have a process where every nightly build is going to run through automated testing, and we'll keep those numbers up to the public as well. It's very, something, that's the core. Like I said, if we're not gaining speed by going multi-threaded, all these other things we're adding in there is just candy because it's not going to help us.
Well, we're already in the break.
Yeah.
But maybe one more question, then we wrap it up. Then there's 50 more minutes for you to return or change over to the other room. So is there any more question? Last question, maybe? One more lanyard to give away? What's the time? No, that was too easy. Any more questions? No? Then I would like to thank you. We wrap it up before the break. Thank you very much for coming and showing us to us. One more reminder, tonight, MetaLab, we'll have the party. Please come, and if you want to give another talk or want something else, please be there. 5 minutes lightning talks. Thank you very much.
Thank you all.